Let's take a look at the runtime of the breadth first search. If we take a look at the algorithm here, the first line where we mark all the vertices in G as unvisited will take order of n time because we have n vertices. Initializing an empty queue will take constant time, so order of 1 times. This for loop will go through for each of the vertex. That means the for loop will go for order of n times. But if we take a look at the for loop, the runtime of the for loop will depend on BFS iter function. So what does the BFS iter function does? If we take a look at the BFS iter function in this algorithm, algorithm 4, we see there is a for loop from line 3 to 9. What it does, for every vertex, it goes through all the adjacent vertices. What do we call the number of nodes that are adjacent to a vertex V? We call that degree of V. That means the runtime of this for loop from line 3 to 9 will be order of degree of V. Another thing to remember here, in the queue that we maintain throughout the BFS algorithm, we enqueue one vertex at most one time. We never enqueue or insert a vertex more than one times. That means this for loop at some point will go through for all of the vertices in the graph. In that sense, if we analyze the whole runtime of this algorithm from line 1 to 10, we can say for each vertex, we will go through its degree time. That means degree of V. So we can sum up all the time the inner for loop will go through. We already know what this term means in terms of the number of edges. When we add all the degree of every vertex, we get 2 times number of edges. That means this term is order of E. That means the runtime of the algorithm here or algorithm 3 in full will be order of n plus E or order of n plus m. So this is what the runtime of the breadth first search. Let's take a look at the runtime of the DFS. The first line, marking all the vertex in G as unvisited, will take order of n time. Then we have a for loop here from 2 to 6. This for loop will go through order of n times. But if we take a look at here, the runtime of this for loop will depend on the recursive call of this function. So we need to find out what is the runtime for this recursive function. That means we need to find out what is the runtime of this algorithm 8. So what does this algorithm does? This algorithm checks each of the edges in the graph, and then if we found a new vertex using any edge, we recursively call the function from that vertex. The number of times each edge in the graph is checked twice in case of if we are talking about undirected graph. If the graph is directed, then each edge in the graph will be checked once. That means what this algorithm is doing is kind of order of E, because at the end this algorithm will check all of the edges either once or twice. So what we can say here is number of recursive call for the whole DFS is n, or number of vertex. Finally, we figure out this for loop will go through order of E times. So the whole algorithm will take order of N plus E or order of N plus M times.